This is Tricky Trig transformation video number 2. Okay, so I'm going to assume that you already watched the first video. So here in the second one, I want to do one that deals with grosser numbers. So I decided to do the one with sine. So notice on this one, they just say describe the transformations. It's actually, this has been reflected over the x-axis. It has a vertical stretch of 5, which implies that the amplitude is now 5. It has a horizontal, a horizontal compression by a factor of 2. And then it moved to the left, pi over 6, and down 1. Okay, so what that means, so watch the first video, but what I'm going to do is I'm going to start with the parent function, because if you don't know the parent function, you're in trouble. I'm going to do any reflections and stretches at the same time, and then I'm going to do the shifts, okay? So on this one, we know that sine goes something, and I'm most concerned that you know how to graph one period. So we want to label this. This goes as high as 1. This goes as low as -1. Here is pi over 2. This is pi. Here is 3 pi over 2. If I'm going too fast for you, that means you haven't studied, little darling, so go study. I'm sorry, I'm not a nice person. Okay, so here's that graph. Here's one period of sine. So now what I need to do, the negative is going to reflect it over the x. So instead of going up first, I'm going to come down first with that one. And then the 5 affects my period. So what I'm doing is I'm going to go 1, 2, 3, 4, 5, and I'm going to go as low as 1, 2, 3, 4, 5. But I also have to think about, did I say 5 affects my period? I lied to you. I'm so sorry. 5 affects my amplitude. 2 affects the period. And so it's a compression of 2. I didn't write down the new period. And all of these, since sine's period, the parent function period is 2 pi, we do 2 pi over b. And so it now has a period of pi. So it's going to do everything it's going to do by pi. So then halfway through here is pi over 2. Halfway through that, we care about that, and then we also care about, I'm so sorry, that's hard to read. But so it's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is how we've broken this apart. So normally, because notice I broke this into, I care about 1, 2, 3, 4, 5 points, but what that does is it takes my whole period and divides it into 1, 2, 3, 4 chunks. Okay, so here's the beginning and the end, 4 chunks. So we're here. We're still at 0, but now instead of going up first, we're going to go down first. So by pi over 4, we're at negative 5. Then we're back to 0. Then we're up to positive 5. Then we're back to 0. So this, and make sure your graphs may not be perfect, but you got to get the concavity at least close. And you're doing something like that. Okay, now we need to do the shifts. So there's 2 ways to think about your x values. We could write down the x values that we care about. And what we're doing is we're moving all of them left. So we can then subtract pi over 6 from each of those. Okay, and that gives us our new values. This is a negative pi over 6. Oh, okay, I've got to think in terms of 12. So this is equal to, what, 3 pi over 12 minus 2 pi over 12? And that's equal to a pi over 12. This is 3 over 6 minus 2 over 6. Well, I'll write it out for you. I lied. 2 pi over 6, which is pi over 3. This is 9 pi over 12 minus 2 pi over 12, which is equal to 7 pi over 12. This is, 5 pi over 6. Life is good. Okay, so now these are the new values that I care about. And another way to get there, hang on, let me grab a piece of paper. Okay, so those are the values that I care about for my x components for all of these. Another way to do it is to say, okay, well, that first one moved to negative pi over 6. And then now they're all pi over 4 apart. Okay, so we can think of this as being an arithmetic sequence, actually. So what I'm doing is I'm at negative pi over 6, or this becomes a negative pi over 12. I lied. I'm writing it correctly. I'm not saying it correctly. I'm so sorry. Guess who needs a weekend? Okay, so negative pi over 6 is negative 12, negative 2 pi over 12. And what I'm doing is they're all pi over 4 apart, which is pi over 4 is equal to 3 pi over 12. So if I add 3 pi over 12, then the next one becomes pi over 12. I add 3 to that, and then I'm at 4 pi over 12. I add 3 to that, I'm at 7 pi over 12. I add 3 to that, and I'm at 9 pi over 12. And I have 1, 2, 3, 4, 5 that I care about. Why am I not getting the same? Hang on just a second. Pi minus pi over 6. I started at negative pi over 6, and I'm adding pi over 4, which is 3 over 12. 3 pi over 12. Oh, I don't know how to add. I'm so sorry. Okay, hang on. Let's see. This is 3. Add 3 more. Add 3 more. I can't add. I'm so sorry. I'm so sorry. Okay. 10 pi over 12. So did you notice what I did there? I knew I needed to get 5 pi over 6, but my 9 pi over 12 was not going to equal 5 pi over 6, and I got confused. So my problem was that I didn't know how to add 3 correctly. So I'm leaving that in there so that you know I'm not perfect, and I don't really care. Okay, so reducing all those fractions, this reduces to pi over 3. This doesn't reduce. This reduces to 5 pi over 6. Okay, so did they match negative pi over 6, pi over 12, pi over 3, 7 pi over 12, and then 5 pi over 6. Okay, I've got all the same x values. So basically my point was you can either take the ones that you have and then do the shift with them and get your new values, or you can figure out the shift tells me I'm starting here, and then how much I'm going to add this a similar amount the whole way through. I don't care how you get there, you just got to get there. So now what we're going to do is we're going to draw our axes, and we're going to start labeling those. So I have a negative, so sorry. I have a negative pi over 6. That's a negative. It's hard to see. I'll write it again. I have a, okay, that's going to be, okay, I'm going to make, so sorry. That's a negative pi over 6. Here's my pi over 12. And then a pi over 3, so they're going to be kind of all spaced this way. So notice I'm not exactly precise, but I'm trying to roughly, so there's 1, 2, 3, 4, 5 points that I care about. Okay, so here's the next one, pi over 3, and then it's 7 pi over 12, and then 5 pi over 6. So I'm trying to kind of keep the scale correct. Do you notice it's going to be twice as wide here as it is there? All right, so now, here was the graph that we had from before. Everybody has to shift to the left pi over 6, which we have done with our x values here. Now everybody else has to shift down 1. Okay, so what was at 0, 0 is now going to be at negative pi over 6, negative 1. Okay, that looks messy. I'm going to use another color. Okay, so it's somewhere in here at negative 1. And then what was at pi over 4 now is here, and it's instead of being at negative 5, it's now at negative 6. So 1, oh, I'm so sorry. 1, 2, 3, 4, 5, 6. So that's this point. Then we come back here. I should have labeled things later, but oh well. And then what was at positive 5 is now going to go down 1 to be at positive 4. 1, 2, 3, 4. So that's roughly here. And then this is going to be back to that negative 1 value that we care about. And I'm doing something. Oh, that was pretty linear. Okay, notice this is concave down and this is concave up. And that is one period of that graph. You might want to tell me 4 so that you know that I know that you know, and you tell me that this is negative 6. Okay, so then in all things, that's one period. Maybe I should put arrows. I'm less concerned about that. But okay, so the period, the amplitude, the asymptote, the domain, and the range. The period, we had said that before, was equal to pi. The amplitude was 5. The asymptote, there are none, but I need you to tell me that. The domain, since this is sine, it's all real, life is good. The range, we went as low as negative 6 and as high as positive 4. So the reason I did, there's that. The reason I did this one is because these numbers got really gross. So I wanted to show you 2 ways that I think through that. And once again, you have to practice. Good luck to you.